Hello and good day, Algebra. We are going on to PO18, which is using something called function notation. Function notation. And the thing with function notation, we spent the last objective talking about how to identify whether or not a relation is a function. And remember, a relation is any collection of ordered pairs, right? A relation could be an XY table. We talked about how to tell whether or not an XY table is a function. A relation can be something that's graphed. And we talked about how to tell whether or not something that's graphed is a function. Well, a relation can also be written as an equation, right? Because as we know, when you have an equation, I'll just put a random one up here, y equals 4x plus 7, we can get ordered pairs from that, right? We can pick a value for x, we can plug it in, we can solve for y, we can get ordered pairs from this equation. Therefore, it's a type of relation as well. But it's not as easy to identify whether or not an equation is a function because you don't look at specific x, y values or look at it on the coordinate plane. So function notation is basically a way to identify an equation as a function. Okay, a way to identify an equation as a function. It's also a way to kind of name and label multiple graphs on the same coordinate plane, right? I've got this, it doesn't show up in color on your page here, but I got this blue parabola graph here. Its equation is f of x equals x squared minus 2x minus 3. Then I've got this purple one, this diagonal line coming down here. Its equation is g of x equals 2x minus 3. Okay. Now this f of x and this g of x mean the same thing, but rather than me saying, look at the equation that's x squared minus 2x minus 3, I can say, look at f of x. And you know exactly which graph I'm referring to because it's got that f of x label. If I said, take a look at g of x, right? It's just basically just a shorter way to identify which graph on the coordinate plane that I'm talking about. So it's a way, we're going to use it primarily to identify an equation as a function, but it's also got that purpose as well. Nathan.
I have a question, but what would be the definition of adding? Like what would, like just like addition?
I suppose get more of something. I don't know, elementary definition. To increase, count on, maybe. Of course, then you can add negative numbers as well, but anyway, yeah. No, not right now. So this question here, for the f of x graph, what is the y value when x is negative 2? Here's where we can use equations and stuff to get ordered pairs, answer questions about graphs. It says for the f of x graph, what is the y value when x equals negative 2? Chase. Warning for you. Naveen, you picked one up as well. For the f of x graph, which means we're looking at this parabola here, right? This is the f of x equation. This is the f of x graph. What is y when x equals negative 2? Colin?
Would it be 6?
When we look at negative 2 on x, we follow this up to where it touches on the y-axis.
I was close.
You were close. My green kind of covered up, but yeah. Okay. When x is 2, the y value, or when x is negative 2, the y value is 5. Okay. It says for the f of x graph, what is the y value when x equals negative 2? So we look for x equals negative 2, right? We're following that up to where it touches the f of x graph, which is the parabola, and that point is right here. That y value is at 5. Yes, Nathan?
I plugged it into that equation, and I got negative 3.
My guess is you didn't use parentheses correctly. Did you put parentheses around your negative 2 when you squared it? This is an accidental lesson here. When you square a negative number using a calculator, this is different than that. And it makes a huge difference to what your calculator does first. Because without parentheses, we talked about this. Without parentheses, what is the base of that power of 2? What was that, Andrea? What? Nope. What is the base of this exponent of 2? What is being squared? Without parentheses, what is being squared? Julian? The 2, right? The 2. This is going to equal 4, and this negative sign is going to jump over, and your final answer will be negative 4. Okay? If you plug negative 2 into this equation and square it, what you want is the second part here. You're taking the x value of a negative 2 and squaring. You need to have parentheses, and that's going to be positive 4 because negative 2 times negative 2 is positive 4. Okay, you're squaring sometimes times itself. So what we just found is called finding f of negative 2. We took the x value negative 2, looked at the f of x equation, and we found the y value of that given x. Okay. This is a new concept for everybody, right? So there's going to be some things that you're going to have questions on. That's okay. Please stop me and ask before we get too far into it. For the f of x graph, what is the x value when y equals negative 4? So we're still dealing with f of x. We're still dealing with this parabola here. It says, what is the x value when y equals negative 4? So we go down to negative 4 on the y-axis. What is the x value when y is negative 4? Andrea? It is 1. Okay? We look at negative 4. We follow this over to where it connects to the f of x graph, and it's right at the bottom. Okay? So I'll put y equals 5 up here, and x equals 1. What we just found is x when f of x equals negative 4. And this is going to be kind of the crux of what we use function notation for. You will be asked to find things like f of negative 2. You'll be asked to find things like x when f of x equals negative 4. Nathan.
So the thing about this is you just put like the little equation thingies on your. Well, I guess you could get a different graph.
Yes. Colin?
What does the F stand for?
So the f is kind of an arbitrary variable. It's simply something to identify that relation as a function. You can use f of x, g of x is another common one, h of x you'll see also. It's basically a way to identify an equation as a function. But, and this is going to be my next point, whether it's f of x, g of x, h of x, or whatever, all three of these are just a fancy way to write y. Okay? All three of those are a representation of the variable y, but we don't just put y because that doesn't tell you whether or not it's a function. By writing y as f of x, as g of x, as h of x, that's what tells you the relation is a function. But it gets confusing because when you read something like this and it says, find x when f of x equals negative 4, really what it's saying is find x when y equals negative 4, which is what I asked you to do up in this top part. Okay? So the next one there, that third one, it says for the g of x graph, so now we're looking at that purple one. For the g of x graph, what is the y value when x equals 3? So you're looking at g of x. I'm giving you the x variable, and I want to know what y is when x equals 3. What do you come up with? Chase? 0? So on the g of x graph, which is the purple one here, we're looking for the x value of 3, which is right here, right? It's not marked, but it skips one. Do we agree that y equals 0 here?
No.
Why not? Chase, why is it not 0? Right, you were looking at f of x, right? G of x, we have to follow this up to where that ordered pair touches our g of x graph, and the y value is 3. Okay? And in function notation speak, what you just found is you just found g of 3. Okay? G of 3 means you're plugging 3 in for x, solving for y, and that's what we just did. Okay? The last one, again, for the g of x graph here, what is the x value when y equals -1? What is the x value when y equals -1? And what we're doing here is we're finding x when, again, remember that g of x is just a fancy name for y. Find x when y equals -1 is essentially what we're doing. Leah, 1, let's check. Here's -1 on the y-axis. Okay, we're looking for where this intersects with our g of x graph, which is right there. That's a +1, and that is correct. Okay. So here's the connection I want you to make. When you see something like this, you're asked to find f of -2 or g of 3. Which variable are you being given? Look at what you did in the first and the third questions here when you were asked to find f of -2 and find g of 3. What variable did I give you? Kaylin, I gave you x. Okay, I gave you x. That's what it means to this section here. Okay, find f of 2 when f of x equals 5x minus 4 means x equals 2, solve for y. Find f of 2 when f of x equals 5x minus 4, because remember, this f of x is a fancy name for y, so really this equation is the same as y equals 5x minus 4. Find f of 2 means x equals 2, solve for y. Okay? So, in the practice, using these two examples here, f of x equals x squared minus 5 and g of x equals 12x plus 10. To find f of 4, which variable are you being given? X. Which equation do you use that x in? The f of x or the g of x? F of x, right? Because it's f of 4. So you're going to plug in, well, I'll write the full equation down. F of x equals x squared minus 5, which is really the same as y equals x squared minus 5. You've been given x, right? So you plug that in for the x variable, and what does y equal? Andrea, did you say that 4 squared was 8?
It's 16.
My heart hurts.
Is it 11?
4 squared is 16, right? And then minus 5, y would equal 11. Okay? Now, part of your directions are to write the ordered pair. What ordered pair did we just discover is part of this relation, y equals x squared minus 5? Maddie? 4, 11, right? You were given the x value of 4. You found the y value of 11. So you know that 4, 11 is a solution. Okay? The next one, f of -3. Which variable are you being given? X. Which equation are you plugging it into? F of x, right? So same equation. F of x equals x squared minus 5. I'm going to rewrite that as y equals x squared minus 5. Nathan, what are you going to remember to do when you plug x? Thank you. Okay. You're going to put parentheses around that -3 because we're squaring a negative value. That negative sign needs to be included. And what is -3 squared minus 5? He says with confidence, right? 9 minus 5, y equals 4. If you got -14 as an answer, you did not put parentheses around your -3 when you squared it. Okay, and that's going to get your wrong answer. What ordered pair did we just discover is a part of this relation? Colin? -3, 4. We were given x. We solve for y. -3, 4 is a part of that relation. Questions so far? Tristan?
When will I ever use this?
You will use this. Good question. You will use this, those of you that are going into any sort of data analysis, or if you go into any financial stuff where you're tracking profit and loss over time, stock market, if you go into stats where you are like graphing, you know how when ESPN, you're watching the World Series and someone hits a homer and it pops up immediately how far it went, right? How do they come up with that? A machine, right? But they can't just say, machine, do this. Like, what's the math behind it? Nathan?
Well, I would assume they could just track the ball with like a camera. That doesn't work like that.
What they do is they essentially make a computer model of the entire park, right? And so when, player X is at home plate and launches the ball, okay, they know exactly, that's a parabola, right? I didn't even really talk about parabolas, probably. They're those U-shaped graphs there. It's got that exact coordinates of distance from home plate and the height. Their computer model, the camera tracks it, puts it in their computer model. So you're half right, whoever said that. And then it gives you the ordered pair of wherever the ball lands, right? And the X value of that ordered pair is how far it went. Nathan? Yes. Thankfully, there were some people who, when they were in 7th grade, paid attention in algebra class, so they know how to program that stuff, because if no one knew how to program it, machines wouldn't do it, right? All the technology that you have are from people who know how to program it, okay? And we need to maintain those people coming through the ranks, because if people don't continue to learn how to program stuff won't get programmed. Eli? Oh, I mean, no. Is it going to change your life? No. Is it a fun little thing? Yes. Do we use this in more important things? Yes. Okay. Satellites, stuff, things like that. That's just one application of it. So anyway, we got 1 minute left, so we're going to stop here. No homework for tomorrow. We'll pick it up then. That's how I math.